Hi everyone, this is a quick demonstration of Chapter 3 Review, question number 6. This is the one about the octahedral die. So there must be 8 faces or 8 numbers. My sample space would have the outcomes 1 to 8. And this is not your regular sort of a die where everything has an equal chance of occurring. They said in the question that it's a weighted die. So the number 1 and the number 4 are a 0.15 chance of occurring, and the 0.5 and the 0.8 are a 0.10 chance of occurring. Now that the other ones apparently are equal. So let's work that out. Well, the probability of a 2 or a 3, so the 2 and the 3 weren't in this list, the 4 was, the 5 was, or a 6 or a 7, well, how much is left over? It must be 1 minus the chance of getting a 1, or the chance of getting a 4, or the chance of getting a 5, or the chance of getting an 8. I mean, it's got to be either one of the numbers. You can't have like a 9 or something silly like that. So the chance of getting a 1 was 0.15. The chance of a 4 was 0.15. The chance of a 5 was 0.1, and the chance of an 8 was 0.1. All of that comes to 0.5. So the chance of getting a 2, a 3, a 6 or a 7 is 0.5. Now, because they were all equally likely, we would therefore say the chance of a 2 is the same as the chance of getting a 3, which is the same as the chance of rolling a 6, or the same as the chance of rolling a 7, and therefore it would be 1/4 of 0.5, or decimal 125. This way, we've arranged things so that all of the different outcomes, the probabilities add up to 1. And that's the important idea behind this one. Now that we know the probabilities of each of our different outcomes, and it's a weighted die because they're not all equal. A regular die, they're all equal, but a weighted die means they put some extra little heavy parts inside there, and it's more likely that the 1 and the 4 occur, less likely that the 5 and the 8 occur, and in between are the chances for the 2, 3, the 6 and the 7. Now the question goes on to say, what are the chances of rolling a prime number? The probability of a prime number. Well, we have to know what the prime numbers are, wouldn't we? A prime number, let me highlight them. A prime number is a number which is only divisible by 1 or itself. So 1 is not a prime number. I know that's a tricky one. 2 is a prime number. 3 is a prime number. 4 is not a prime number, it divides by 2. 5 is a prime number. 6 is not prime, it divides by 2. It also divides by 3. 7 is prime. 8 is not prime. So I want the chances of a 2 or a 3 or a 5 or a 7. Let me write that down. Chance of 2 or 3 or 5 or 7. Well, that's the chance of a 2 plus the chance of a 3 plus the chance of a 5 plus the chance of a 7. There are no overlaps between them. Now the chance of the 2 was 0.125. The chance of a 3 was 0.125. 0.125. 0.125. A 5 was different. A 5 was only 0.1. And the 7 was 0.125. Now what's all this going to add up to? 0.475. I think that's the chances of rolling a prime number. And the next bit said the chance of a number less than 5. Chances of getting a number less than 5. So that's either a 1 or a 2 or a 3 or a 4. So chance of a 1 was, oh, what have I done? Oh goodness, I didn't mean to do that. Get rid of that somehow. Okay, under control. Had a mild panic attack there. Okay, so the chance of a 1 is 0.15. The chance of a 2 and a 3, well, the 2 and the 3 were both 125. 0.125, 0.125, and the chance of the 4, where is it? It was also 0.15. So what's this going to end up being? 0.15 and 0.15 is 0.3. That's 0.25. I think together we will have a combined probability of 0.55. Okie doke. That's a nice little question. The main idea behind it was this stuff at the beginning here about the probability of all the different events in the sample space has to add up to equal 1. Okie doke. Thanks for asking.